Hey everyone! In this video we are going to look through some examples of solving compound right triangles. A compound right triangle just means it's a problem that has more than one right triangle in it. I can go ahead and mark this just so that we know that it's a right triangle, but let's go ahead and get started. In this problem we have two right triangles, one on the right and one on the left, and we've been asked to solve two different unknowns, x and y. And although these could look a little overwhelming at first, the trick is to realize it's just two separate triangles, and we want to solve them one after the other. In order to do this, first find the triangle that you have the most amount of information. So this triangle on the left, we know the 12, but we don't know the x, and we don't know the y. That's a strong hint that that is a bad triangle to start with. On the triangle on the right, we know the 5 on the bottom, we know this angle 55 degrees, and the only thing that we need is the x. Bingo! We've found our triangle. So I'm just going to go ahead and just do a little sketch of this triangle over here. And we're going to just look at it individually. It's a right triangle, there's an x, there's a 5, that's a 55 degrees. And all of a sudden, when I put this triangle drawn like this, it's not so scary. This is a little SOH CAH TOA problem. Here's our theta. We don't know the hypotenuse. We're looking for the opposite, and we know the adjacent. So we can actually write this out as tan of 55 degrees equals our opposite side, which is the x, over our adjacent side, which is the 5. We can go ahead and multiply this 5 up, and in our calculators, we're going to put 5 tan 55 degrees equals x, and that's going to give us x equals 7.14. We've got our x. Now that we have that x, we can actually work on this second triangle, because instead of having two unknowns, now only has one unknown because we know what x is. It's 7.14. So if I were to just quickly sketch this triangle again, right down here like this, and it's a right angle, and it's a 12, and our x is 7.14, and we are looking for y. If you have been asked to solve this isn't so scary. It's not a big compound triangle. It's one little triangle where you know two sides, and we have been asked to solve this hypotenuse. I'm going to clean up some space, and we're going to solve for y. Okay, cleared up some room just so that we can keep writing, but we want to keep some relevant stuff. We want to keep our x up here and our diagrams up here. When we are not dealing with any angle, this is an example of Pythagorean Theorem. A squared plus b squared equals c squared, where the c is the hypotenuse. So in this case, c is the y value that we're looking for. This 12 and the 7.14 can be our a or b, and it doesn't matter which is which. So we can say 12 squared plus 7.14 squared equals our y squared. Tidy this up. 144 plus 50.98, and just put those in the calculator and square them. This is 12 times 12, 7.14 times 7.14 equals y squared. Go ahead and add these together. The 144 plus 50.98, 194.98. I know that's really close to 195. I just don't like rounding until I get all the way to the end. That equals y squared. And for our final step, we're going to square root both of these, and we end up with y equals 13.96. Compound triangle, but because we broke it into two little triangles, we realized that we can either use our SOH CAH TOA right angle tricks, or we can use Pythagorean Theorem. Let's go ahead and do one more example. All right, here we go with the second example. This is another compound right triangle because we have two right triangles. I'm just going to go ahead and mark my little squares just so you can be sure that those are little right triangles. We have the little one inside, and we have the big one. It's just the little ones inside of it. But this is still two right triangles. Let's check and see which one we have the most amount of information for. For our big triangle, we know the bottom because it's 2 and a 5. That makes this a 7. But we don't know this big X, and we don't know this theta here in the corner. So we have two unknowns for this big triangle, which is a big red flag that we don't start with this one. The little triangle, we don't know theta. That's our unknown. But we do know this opposite side. That's a 7. And we do know this adjacent side here. That's a 5. That's two pieces of known information, and that's enough to get started. I'm going to go ahead and redraw this little triangle here, just filling in what we know. If I redraw this little triangle here with a theta and our 7 and our 5, we can see that this is an example of SOH-CAH-TOA, where you need to use sine, cos, or tan. Because we know the opposite of theta and we know the adjacent of theta, we can say that tan of theta is equal to our opposite side, which is 7, divided by our adjacent side, which is 5. In order to get our theta, we have to use our arctan. That's our inverse tan, that tan to the -1, if that's what you're calling it, of 7 over 5. And you will get that theta equals 54.46 degrees. Now that we know our theta, we know this little theta down here, it's 54.46 degrees. We now have more information in our big triangle. Let's go ahead and solve that one now. So if we take our big triangle, it still looks just like this. Looks a lot like the other triangle, except across the bottom, it's a 7. We don't care about this height. That's not labeled. It makes no difference to us. But we're looking for this X, the hypotenuse. And now we know this little angle down here. It is 54.46 degrees. This is enough information. Once again, we're doing another SOH-CAH-TOA problem. We don't know the opposite. We do know the adjacent. And we're looking for the hypotenuse, which means this is a cos. Cos of 54.46 degrees is equal to the adjacent side, which is 7, over the hypotenuse x. And you can see once we start breaking this into two triangles, these just become our little one-step SOH-CAH-TOA problems all over again. In order to get rid of this x on the bottom, we bring it up to the other side. And we have x cos 54.46 degrees equals 7. We finish this off by saying x equals 7 over cos of 54.46. That's just us dividing both sides by cos of 54.46. Gets x all by itself. Chuck that right into the calculator, as is 7 divided by cos of 54.46, which is just rearranging the SOH-CAH-TOA, and you're going to get x equals 12.04. If you feel like you still need some practice with your basic SOH-CAH-TOA, there's a video on that. Feel free to check it out, but the point of this video is helping you out when you see two triangles in one problem and how we can just go ahead, break those down into two smaller triangles, and once they're two little itty-bitty manageable triangles, you can use your skills of Pythagorean Theorem or SOH-CAH-TOA and you can solve everything you want to know. I hope that this was helpful. If you have any questions at all, please feel free to leave them in the comments below. Thank you very much.